Hello guys, welcome to our YouTube channel. Welcome to Add Maths Plus Maths. I am now doing the revision lesson in Algebra Part 4 and we will now be focusing on upper bound and lower bound. Okay, so upper bound and lower bound problems will follow. Okay, question number 1. The first question is this one. Carmen spends 5 minutes, correct to the nearest minute, preparing one meal. Okay, so 5 minutes, correct to the nearest minute, preparing only one meal. Remember this? She spends a total time of T minutes preparing 30 meals. T minutes preparing 30 meals. We need to find out the boundary or the limit of the T or the total time. Now, how to find out the boundary or the limit of the total time? To find out the boundary of the total time, we have to find out first what is the lower boundary and upper boundary of the time in preparing one meal. Okay? To find that out, we have to consider this statement. It says correct to the nearest minute. How many minutes is that? 5 minutes. But it's correct to the nearest minute. So it means on the right side will be 6. On the left side will be 4. Because 5 plus 1 is 6. 5 minus 1 is 4. Okay, next. Since I have 4 and 6, 4 on the left side and 6 on the right side, I'm going to find out the lower bound by finding what is in between 4 and 5. Okay, this is the lower bound. Okay, lower bound is 4.5. The upper bound is in between 5 and 6. This is the upper bound, which is 5.5. Okay, so how will I look for the total time? Basically, I will just multiply it by 30, the lower bound. Okay, because the lower bound of preparing one meal is 4.5, I will multiply this by 30, okay, which is equivalent to 135, and I will multiply the upper bound in preparing one meal, which is 5.5 times 30 to find out the upper bound of the total time, which is 165. Okay, so my answers now are lower bound is 135 and the upper bound is 165. Okay, as easy as that for question number 1. Let's move on to question number 2. To raise money for charity, Jalaj walks 22 kilometers. Okay, Jalaj needs to walk 22 kilometers. Okay, every day she needs to walk for 5 days to complete the 22 kilometers, correct to the nearest kilometer. Complete the statement in the answer space for the distance d kilometer. Okay, he walks in one day. So it means I need to find out first what is the lower bound and upper bound of the total kilometers. Okay, so I have 22 and 23, 21 on the left side. So I'll have the lower bound is 21.5 and the upper bound is 22.5. This is the lower bound and this is the upper bound. Okay, now to find out what is the distance he walks in one day, okay, you have to divide the lower bound to 5. Okay, 21.5 divided by 5 and then 22.5 divided by 5. Okay, so I have this. Let's just compute that on our calculator. I have 21.5 divided by 5 is 4.3 kilometers is our lower bound, and 22.5 divided by 5 is our upper bound, which is 4.5. So it means I have 4.3 and 4.5 as the limit or the distance traveled by or walked by Jalaj in one day. Okay. Next, letter B, he raises 1.60 for every kilometer that he walks. Calculate at the least amount of money that he raises at the end of the 5 days. Okay. Remember, okay, she will be walking. Okay. The least amount is, or the least kilometer that she can walk here is 21.5, which is the lower bound. Okay, so I'll put 21.5 kilometer is the least number she can walk. Okay, then multiply this by $1.60, which will be 21.5 times 1.60 times 1.60 will have 34.40. So this is the least amount that she can or he can earn or raise in 5 days. Okay, that's for question number 2. Let's move on to question number 3. The distance between Singapore and Sydney is 6,300 kilometers. Correct to the nearest 100 kilometers. A businessman traveled from Singapore to Sydney and then back to Singapore. He did this 6 times in a year. Between what limits is the total distance he traveled? Okay, so question number 3 says 6,300 kilometers, correct to the nearest 100. Okay, so if I will put at the center 6,300, since it says correct to the nearest 100 kilometer, okay, this should be 6,400 on the right side, and on the left side should be 6,200. Okay, the lower bound now is 6,250 and the upper bound is 6,350. Okay, next, since I have this idea, okay, 6,250 and 6,350 as our lower bound and upper bound, okay, he did this for 6 times in a year. Okay, so I will just basically multiply it by 6 so that I can find out what is the total distance traveled by the person or the businessman from Singapore to Sydney. Okay, so 6,250 times 6, which is equivalent to 37,500, and 6,350 times 6, which is equivalent to 38,100. So this is now the lower bound, 37,500, and the upper bound is 38,100. Okay, next let's move on to the 4th question. In 2005, there were 9 million bicycles in Beijing. Correct to the nearest million. So since it's already million, okay, I'll just put in 9 million on the center. Okay, 10 on the right, 8 on the left. Okay, let's continue reading. The average speed distance or average distance traveled by each bicycle in one day was 6.5 kilometer. Okay, so 6.5 kilometer. I'll put on the center 6.5. Correct to one decimal place. So it's one decimal place, so it means this is 6.6 and this is 6.4. Because we only have one decimal place, so one decimal place is 5, the 5 there, you add 1 to 5, it will become 6.6. You minus 1 to 5, it will become 6.4. Okay, next, work out the upper bound to the total for the total distance traveled by all the bicycles in one day. Okay, so since we are working out the upper bound, and if you are going to analyze the problem, 9 million bicycles, okay, times the distance times the upper bound of the distance will give us the upper bound for the total distance. So we only need the upper bound. This one is 9.5. Here the upper bound is 6.55. Okay, so the upper bound for the total distance, okay, upper bound will be equivalent to 6.55 multiplied to 9.5, which is equivalent to 61.75. 61.75. Okay, that is in million because 9.5 is in million. This one is in million. Okay, so it will be 61.75 million kilometers. Okay, next, let's move on to question number 5. A fence is made from 32 identical pieces of wood, each of length 2 meters, correct to the nearest centimeter. Okay, you notice here it says 2 meters, but it says correct to nearest centimeter. And you know, okay, that when we are talking about meters to centimeter, okay, how many centimeters are there in 1 meter? There are 100 centimeters. Okay, so it means it is the hundreds. Okay, so if I will put 2 at the center, okay, I will put 100ths additional going to the right, so it's 2.01. I said 100ths. Hundreds. Okay, and I will minus 100ths to 2, it will become 1.95 or 1.99, sorry, 1.99. Okay, next, so what is the lower boundary? Because the question says calculate the lower bound for the total length of the wood used to make this fence. So I am only going to consider the lower boundary, which is 1.995. Okay, in between 1.99 to 2.000 or 2.00. Okay, next, I will multiply this one by 32 because there are 32 identical pieces. 32 times 1.995, and 1.995 times 32 is equivalent to 63.84. 63.84. So our answer here is 63.84. Okay, let's move on to the 6th question. Ashraf takes 1,500 steps to walk d meters from his home to the station. Each step is 90 centimeter correct to the nearest 10 centimeters. Correct to the nearest 10 centimeters. So I'll put in a line again. I'll put on the center is 90, which is given. Since it's correct to the 10 centimeter, 90 minus 10 is 80. 90 plus 10 is 100. So the lower bound is 85. The upper bound is 95. Okay, this is lower bound. This is upper bound. Okay, to find out the lower bound and upper bound for D, okay, I have to, so Ashraf takes 1,500 steps to walk D meters. Okay, each will give us 90 centimeter. Oh, okay. So it will be 1,500 divided by or multiplied to 85 and 1,500 multiplied to 95. That will be the lower bound, but you have to uh, change this into meters. Okay, why? Because it's written there meters, so 85 times 1,500, okay, is equivalent to 85 times 1,500 is, sorry, 127,500. Okay, divide this by 100 because in 1 meter there are 100 centimeters, so it will just become 1,275. Okay, and then I'll have 95 times 1,500. Okay, I'll come up with 142,500. I'll divide this by 100. I'll come up with 1,425. So my answers here are 1,275 and 1,425. Okay, so that's question number 6. So be careful, though, if you are answering questions like this, you have to take note of all the details of the problem. Okay, next, number 7. The sides of a rectangle are 6.3 centimeter and 4.8 centimeter. Okay, so I have two things. I have 6.3 and I have 4.8. So if you notice, guys, I keep on drawing line. Okay, why do I need to draw line? So that I don't get confused. Okay, because sometimes it's confusing to find out the lower boundary and the upper boundary. Okay, now it says correct to one decimal place. So on the right of 6.3 is 6.4, on the left is 6.2. Okay, on 4.8 on the right is 4.9, on the left is 4.7. Okay, calculate the upper bound area. Okay, so if you notice, area is equivalent to length times width. Maybe the length is 6.3, the width is 4.8. Okay, since we are just multiplying, will just be area upper bound, or the upper bound area is equal to the upper bound of the length times the upper bound of the width. Okay, so the upper bound of the length is 6.35 and the upper bound of the width is 4.85. So I'll just basically multiply that, 6.35 times 4.85, okay, which will be equivalent to 30.7975. 30.7975. Okay, you can write your answer as 30.8, but I want it to be written everything. Okay, I just want to write everything. Okay, anyway, you write your answers as 30.8. It will be the same as 30.798. Okay, or 30.80. Okay, if you want four, two decimal places. Okay, but I prefer to write everything. Okay, next, let's move to number 8. Joe measures the side of a square correct to one decimal place. He calculates the upper bound for the area of the square as 37.8225 centimeter squared. Work out Joe's measurement for the side of the square. Okay, so the given is we don't know. Okay, this part is what we don't know. Okay, since it's upper bound, okay, we need to find out what is this first. Okay, so let's say, how do we look for this the area of the square? Area of a square is always equivalent to side squared. Okay, and you are squaring the upper bound. Okay, upper bound side. Okay, that is the value of the x, wherein the area is equivalent to 37.8225 is equivalent to x squared. Okay, you square root both sides. Of course, you are not going to make it positive negative anymore, because we are talking about length, which tells us that we don't consider the negative value. Okay, so we only consider the positive value, and square root of 37.8225 is 1 point, oh no, it is 6.15. 6.15 is the value of this x. Okay, so if this is 6.15, okay, you will notice that it says correct to one decimal place. Or no, this is not x. 6.115 is the boundary of, okay, so let's extend this. This is the lower boundary, this is the upper boundary, 6.15. Okay, if this is 6.15 and it is correct to one decimal place, one decimal place means you have to add 0.05 to the right. You have to add 0.05 to 6.15 to get the one on the right, which is 6.2, and you have to subtract 0.05 to get the one at the middle, which is 6.1. Okay, so the length of the side of the square is equal to 6.1. Okay, so the answer here is 6.1. Next, let's move on to question number 9. The mass of 1 centimeter cube of copper is 8.5 grams. Correct to one decimal place. So it means I'll put 8.5 at the middle. Since it's correct to one decimal place, this is 8.6 on the right and 8.4 on the left. Complete the statement about the total mass of 12 centimeter cube of copper. I need to find out the lower bound, which is 8.45, and the upper bound, which is 8.55. I'm referring to the 1 centimeter cube of copper, and then multiply it with 12, so 8.45 times 12 and 8.55 times 12. 8.45 times 12 will be equivalent to 101.4, and 855 times 12 is 102.6. Not so much difference. I have 101.4 to 102.6. So this is now the boundary of the total mass. Now let's move on to the last question. Question number 10. 1 year ago, Ahmed's height was 114 centimeter. Today, his height is 120 centimeter. Both measures are correct to the nearest centimeter. So, if I am going to put correct to nearest centimeter, it will be 114, 115 on the right, and then 113 on the left. Then I have 120, 121 on the right, and 119 on the left. Remember, if I am looking for the increase, I have to subtract the present height of Ahmed to the, I have to subtract the present height of Ahmed to his height 1 year ago. Okay, so when we do subtraction and we are looking for the upper bound, upper bound is always equivalent to upper bound minus lower bound. But if we are looking for lower bound, it is always equivalent to lower bound minus upper bound. So in here, I need the upper bound of his height today, which is 120.5. And I need the lower bound of his height 1 year ago, which is 113.5. So the upper bound now is equivalent to 120.5 minus 113.5. Since I subtract, we'll have the answer 7. So the answer is 7. Thank you for watching this video. If you have learned something about upper bound and lower bound, please don't forget to like and subscribe. Share it with your friends. By the way, we'll be doing a lot more of revisions. The next revision for this is solving linear equation. So part 4 of the algebra part of our revision lessons will be solving linear equations. So try to subscribe if you haven't subscribed yet. Please like the video if you have learned something in watching this video. Thank you and God bless us all.